Hi, everyone. Welcome to High Availability for August 9th. Figure we can get started. I hope we have everybody this week. I think the action item was to go ahead and read through the documentation that was provided in the repo, the proposal XSightLabs the last time, and maybe think about AMD's implementation and come armed this meeting with that. So maybe we could get started. I'm going back and forth trying to let everyone into the meeting. So yeah, want to get started, Marian?
Yeah, hi, Christine. I thought we had the proposal on an agenda, right, for today? Or do we need to close something from the last week?
Here we were gonna cover John's paper, and
yeah.
And Balky, were you Balky created a PR for us to look at if everyone had a chance, and then that's what I recall happening.
Yeah, right. So for today we had Q&A or general presentation. I don't know which way we want to go with the proposal.
I mean, I think we could give an overview of it, and then if people want to ask questions,
do you want me to present, John, or do you want?
Yeah, that would be great.
Okay, let me find it and I'll present. Talk. Just so y'all can see how I get there, I'll share my screen. This one, right? The new ideas one?
Yeah.
Good.
Yeah, so basically what this is proposing is not like any specific HA algorithm, like Pensando presented last week, an approach where, the packets are sent and returned back to the primary. I think that approach is sort of understood, it's reliable, and that I would call that sort of like an algorithm. What this is really like a framework that would allow for like multi-vendor interoperability while still allowing like vendors to implement their own algorithms. And like the way it does that is by sort of putting like most of the intelligence of HA as part of like the transmitter functionality. The end of the HA link that's transmitting state. And then the receiver just implements like a simple kind of stateless operation. It either receives packets and it processes those packets, or it receives just like state updates and it processes those state updates. And it's really the sender that decides when to send state updates, whether reply should be returned, whether that reply should be the full packet that was sent, or whether that reply should be truncated. And so essentially, it's just kind of the wire protocol for communicating packets or state updates. Again, it like really allows the transmitter to have the intelligence and the receiver to just do some simple stateless operation. So for example, what Pensando showed last week, as far as an approach of sending packets and having them returned back to the sender, like that approach fits within this framework. One of the capabilities of this framework is the ability to batch, like multiple packets or multiple messages within a single transport packet. But the receiver decides whether, what the maximum batch size should be. So if the receiver only wants to deal with one message at a time or one packet at a time, the receiver specifies that it can do a maximum batch of one. The sender can also decide, the receiver may say that it supports a batch size bigger than one, but the sender can choose to only send one at a time if the sender only wants to send one at a time. And so, this is really, again, it's a way to try to allow for flexibility, but at the same time, allow for interoperability and also the ability to test each HA implementation and to really try to quantify each implementation in terms of its ability to not lose established connections, to test how much bandwidth an implementation uses on the link. And so that's kind of an overview of what this is attempting to do. Not sure if people got a chance to read it, but we'd welcome any feedback or comments.
And I think it says exactly, what you just talked about, the whole blocks of text here say exactly that.
Mm-hmm.
Okay, so this proposal doesn't have much details, right? So it's a generic approach, to approach HA. So I'm not sure how the vendors going to implement this one.
Right. So I think this is a framework, right? And then on top of this framework, we can specify, let's just say, like modes. Like one mode may be just like the AMD mode that the AMD approach that was described last week. We could say that's one mode that can operate on top of this framework. Another mode, let's just start with that. Maybe every vendor is capable of implementing that mode. Okay. Another mode might say, you know what? Instead of sending just one packet at a time, I'm going to batch them up and send multiple packets at a time. So there's incremental improvements that you can make on top of, say, that base mode. And there's no requirement that any vendor has to implement anything above that base, but the vendors have flexibility to do that. So this was really an attempt to create a framework for incremental improvement in HA without having to define it all up front. Maybe I'll just sort of throw something out there. What if you took the approach AMD talked about last week and you said, instead of sending the packet, the sender will buffer the packet and it will send a digest of the packet and it will get an acknowledgement back, and then the sender will forward the packet when the acknowledgement comes back. Well, that seems pretty complicated, but it has some advantages. It uses less link bandwidth. And so this framework would allow for such an approach because it only requires the receiver to do this very simple stateless updates of its state. But the sender could choose to do the buffering. It could hold the packet until it gets the acknowledgement, and then it could send the packet, to the endpoint. And so that's really what this is trying to do. And intentionally, doesn't have the details of what algorithms you want to use because it's allowing, that to be either developed by each vendor or to be, decided incrementally. You know, and I could see like different deployments might have different requirements. You know, some deployments that have like lower connection per second requirement, maybe there's nothing special you have to do other than just to send the packets and have them returned. Maybe other deployments that have very high connection per second requirement, you need to do batching and compression. So, you know,
Okay, yeah, but I think are we really talking about the HA between different NPU or a different DPU, or the because the interop between the different DPU, I think it's very problematic.
so, you know, we actually like started this whole HA discussion by like proposing that each vendor only be interoperable with themselves. And I think Gerald like was really pushing for interoperability. And I think, you know, he has reasons for it. Like he wants a common way to be able to test everybody's HA. He wants to be able to look at the link between the two DPUs and be able to understand, you know, what's being passed on the link. And so, you know, I think the community may be okay with, you know, sort of a high level HA requirement where each vendor can be interoperable with themselves. But I think Gerald had challenged us to try to come up with like a multi-vendor interoperability. He also has made the statement that it probably wouldn't be deployed as multi-vendor HA, but that, you know, that we should consider this goal of trying to make the implementations be interoperable for these benefits that he sees from it.
John, I think it was crawl before we could walk. It was, you know, interop with ourselves first and with a longer term goal of interoping between multi-vendor.
Yeah, I think agree with it. The HA is a very complicated stuff, right? So even I remember when we were testing some HA, not specific for this DPU, but some other HA, right? So the industry have the experience, even the same vendor, same hardware, but different software version will not be able to interact with
Yeah.
itself, right? So
Yeah.
because then I think I think the challenge of interop with a different vendor is that, okay, how are we going to align those different releases? And the testing metric is just huge, right?
No. But the way that this interoperates is by defining like a very simple receiver, and that's like invariant. It's like from release to release, the receiver of the state update always performs like a very simple function. And all of the sort of complexity of HA, the burden of it is put on the transmitter side. And so from that perspective, like the receiver that's designed on day one is interoperable with all future transmitters. That's the goal of what's being proposed here. It's kind of like I
No,
don't know.
but you said, right? So for example, the AMD approach is basically a subset of it, right? So a subset of this approach. But when I look at the AMD approach, I have to admit, it's they divide into different stages, right? So there's initial stage and there's the incremental update, and they leverage the data plan, to be sent from one to another and then coming back so that make sure the state is in sync, right? So I
Yep.
I think there are complexities in those receivers to how to pass those state and make sure, the state being reconstructed in their own state machine, and how to handle those failure cases. For example, if the packet is not just is lossy between, sender and receiver, then how those state replication be naturally recovered in their approach, right? So I think there's a lot of details. I'm more no, I mean, fine. It's in the concept level, it just stay sync between the sender and receiver. But when you boil it down to all the details, how the HA is implemented between the protocol between the sender and receiver, there's a lot of complexities. So that's what I'm worried about, right? So, you know,
Thi-
be able
thi-
to interrupt between different vendors.
Yeah, this proposal doesn't, make any kind of like assumption about like how to deal with lossy packets or lossiness in the channel. It just provides the mechanism to be able to deal with it. So like all of those complexities that you're talking about like exist, but they can all be mapped on top of this framework. That was the idea of what we are proposing here.
John, I have a question because you mentioned the Pensando proposal will fit into this mechanism.
Yeah.
From what I heard last time, I couldn't stay for the whole call, but there were two types of synchronization mechanisms that were described there. One was the software path, and the other one was the data path, which is inline. How does this fit into both of those different ways of synchronizing?
Yeah. Okay. So basically, the way this works is that every every state update is its own independent message. And so it doesn't really matter whether that state update is originated from some background process or from the data inline and the data plane. Each state update is its own independent message, and the sender basically specifies in the message how it wants the receiver to respond to the message. Or if the receiver even needs to respond to the message. And the receiver basically just does what it's told to do from the sender. So the sender is basically instructing the receiver on what to do with the message. And so like from that perspective, it doesn't really matter whether the message originated from the background, like scanning of the connection table, or whether it originated from the inline and the data plane. The receiver gets the message and just follows the instruction of the sender on what to do with it. So like that's how I believe, when I say like what Pensando presented could map onto this, I don't think, it can map onto this without them making some minor changes, but I think that their approach like does map onto this framework.
Would that be like mode 1, John?
Yeah, that would be like mode 1.
Yeah, can I make a couple of comments?
Yeah.
First, I want to share my screen because I'm glad I'll just share it temporarily.
And Gohan, just to catch up, we've been going back and forth with this whole perfect sync eating up the bandwidth for at least 3 or 4 months now, and how to do this.
I just wanted to rehash my initial perceptions of this proposal. Can you see my screen? And I remember sending this right away because I was impressed with its simplicity and elegance. And I don't think it's in any way a vote against any other approach, but I endorse this a proposal of John's because it's so simple and elegant. And I think it'd be very worthwhile to actually someone to proceed along this and actually implement.
I mean, sorry. I think it's because if it's looks simple because it lack of details. That's my read, right? So, I don't think if John had a lot of details in his proposal, I don't think it's that simple, right? So.
Well, I didn't say that the overall solution was simple. What I said was the framework and this fundamental principle behind it is simple and elegant.
No, but we cannot talk about the vendor interop just with approach, right? So we need the details.
Well, I think
we cannot evaluate those things without any details.
Okay, I would like to finish saying what I had to say, please. It would be I want to complete a thought. I think an approach to evaluate the merit of this is for someone and who may be its strongest proponents, XSight, to work on the next level. You don't necessarily need the community's participation to do your own project and develop it further, and show a little more detail, and actually maybe have a functional working model of it. And if people think it's worthwhile, people are free to go ahead and join in on this and let it prove its own merits. It doesn't need a giant debate, right? You can actually bring more to the table, and you'll also find out, wow, does it handle these certain use cases? We can come up with use cases to test it against. I think if we argue a lot about all these different complex cases, we're never going to get anywhere. We need to start going forward with something. And I think this is, like, to me, the simplest framework and conceptually to start from. That's just my
Yeah,
opinion.
I agree. I agree with that. I think, instead of treating this as a framework that everybody else, can, take this mode 1 or mode 2, I would suggest XSight, to have a detailed proposal, and then we can evaluate, right? So, and
So we
also,
started that way. I mean, we've spent endless hours, like, internally working through, like, details of how to do HA. And you're right, it's a complicated thing. The problem is when you come to the table with something detailed, there's immediate disagreement because everybody's architecture has different trade-offs. And everybody wants an HA that works well with their architecture. So we can come to the table with something that works really well with ours, and maybe it's the best HA you've seen. Maybe it uses the lowest bandwidth. It has perfect fault tolerance. All of these things are great, but we're not going to get agreement from, and this is what happened. There was a lot of disagreement. NVIDIA had an idea of what they wanted to do that was completely stateless. We had ideas that were stateful, and I think that we actually, like.
okay, I get it, right? So, different vendors cannot agree on a common HA protocol to interop. I'm fine with it. So
Okay, but Gerald isn't.
right?
So we've been going based on the input that we've been getting from Gerald.
Yeah, I can have an internal thing with Jared, right? So, because we also have this internal thing. I don't think we need the, any community member have a strong, the ask that we need to do interop between different vendors.
No,
Apart
this is
apart from
Rohan,
apart from
I am
apart
on
from
the call, and
yeah.
we do have interop at different levels. We've already got it at the API level. And the second stage was at the message level, and we never thought that there wouldn't be more than one mode, which allows people to optimize their hardware initially. So the goal here was not to stop anybody from doing whichever mode they wanted to do, because we realized that, at least initially, it will be very difficult given that the hardware existed without any guidance to any particular mode. But the messaging that John's bringing forth could be used by anyone in any mode, or, it could be used by Intel, it can be used by Pensando, it can be used by anyone because it's very general. And it at least allows interop that we can see the messages, we know what they mean. And we didn't think we were going to get to the interop at the actual mode level on this round. I don't see a reason why not to have a common transport. Unless somebody comes forth and says, no, my hardware just can't even handle that transport, which I have a hard time believing, then why would we not? It should be a goal until people can come forth and say, I would love to do that, good goal, but I can't do it. My hardware just can't do that. If that were the case, then we could have that discussion, but I haven't heard anybody after John's proposal say that that was the case, that they couldn't use this common transport protocol, which is so flexible that it accommodates everything that anybody's ever talked to on the HA community about what their scheme might be. It seems like it fits all of them. So that would be my ideal goal. If we can't reach that, we can't reach that. But I haven't heard anybody say that they couldn't accommodate this common transport protocol yet. Not a single company saying that yet. And if they can't, I'd like to know why. And because this is pretty encompassing of what every single company has said they would like to do.
But it doesn't really help us, right? So, you know.
But it does. I mean, we have common messaging. We can actually read those messages as opposed to just figuring out like, oh, just a bunch of gobbledygook on the wire.
No, but it's it's really different, right? So, because if you talk about detail map, because there's a inline update, there is a control plane update. So one of them, I assume you're going to use like TCP, other one is using the, you know, the individual packet which is lossy. You know, the TCP could be
But the
basically
messages
reliable,
are
right?
the
So
same regardless of whether
no,
it's
no, I
using
don't think the
TCP or not.
message will be the same. You know, the TCP, there's a lot of if it's a control plane, there's a lot of flexibility. You can craft those messages. It doesn't have to be, you know, for frame, right? So it can be a simple message digested connection. But you know, when you go to the inline data plan, there's less flexibilities, right? So the packet format there, you know, due to hardware constraint can be, you know, cannot be aligned perfectly for each of the ASIC vendors, right? So
I had
Yeah, well,
one
I haven't
similar
heard anybody say
question.
that, Gohan. Like, there's nobody saying that they couldn't fit into this messaging scheme.
So, Gerald, one question that I've been
but
thinking about.
it doesn't help you, right? So you have to be exactly same in order to interop.
No, we're not talking about interop of HA, Gohan. I think we all agree, like, we're not going to quite get there this round. We're talking about how we get as close as possible this round, which was the APIs and the transport, and leave the interop as far as the scheme. I mean, we're going to have to accept different schemes, but the APIs are common between everybody. This messaging could be common between everybody. And then, yes, the details of how people do HA, I'm afraid this round they're going to be different.
No,
But
for
our
the
goal should
API,
be over
for,
time to make them the same.
but for the API, just to clarify, for the API, it's a northbound API talk to the SDN controller, right?
Sure, but it's how we program HA. So there's a lot of commonality there, and even in functionality that we're asking for. So we've talked about what's needed there. Michael's got on here and also asked for like certain things in that, and we came to conclusion that we can have commonality there and all the northbound and what the HA must do. And so we did that, and now we moved on to the transport, hoping that we can do the same thing there, knowing that the final solution of the HA, of course, is going to be different this time around. That doesn't mean that we don't strive for as much commonality as possible, though. So I need somebody to come forth and say, yeah, this message format won't work for me. My hardware can't do this, because it's very flexible. You could send whole packets with metadata with this. You can
But
send.
I don't see the message format in the proposal. Where's the message format?
Okay, this is Bud here from XSight. So the purpose of this document was really to sort of introduce the idea behind the message format, but not to define it. We were a little apprehensive in proposing too much at once. So the idea here is to get general agreement on the idea of like the complicated logic in the transmitter, a simple stateless receiver. And if we could agree on that, then we can go to the next level and say, okay, this is our proposal for the actual format for those packets and the detail on what the receiver does. So just to take a step back, so in general, like we think between the two HA peers, there'll be a control plane channel and a data plane channel. This proposal is really addressing the data plane channel, which is the more difficult of the two. The control plane channel, we assume there'll be an exchange of capabilities and some other things that go on periodically. It's stuff that's low performance and probably easy, we assume easy for vendors to be flexible with. The most challenging part was the high performance requirements of the data plane channel, and that's what this is focused on. So you're right. There's no packet format proposed here, and there is a lot of detail missing here, but that was intentional.
Intentional, yeah.
So in the data path, if you were to have inline synchronization between the master and standby, we will not be able to change the transport, right? Because it will just be mirrored. Can you please answer this question?
No, it's not like you're simply mirroring the packet. First of all, like you would have to encapsulate the packet with an additional UDP header. So there's some encapsulation, but there's also the ability to not only send the packet, but to send opaque information with the packet, and the ability for the sender to say that it would like to get that opaque information back as a response. So, it's not simple mirroring, but let's just say the mode 1, which is like what we think is the simplest implementation of HA, it's pretty close to mirroring.
I see. So there'll be additional data and additional encapsulation in case of mirror.
Yeah.
Even the way we do it today, there's a little bit of metadata that's sent along with the packet. So it's not different than this actually. You get the packet plus a little bit of metadata. So
then
not much different than exactly what's being proposed.
Okay, then it should be able to bypass the slow path there, any lookups, and go through the fast path in the standby.
Yes. It must by design. It has to go through this fast path.
Right.
Hey, Gerald and Guhan, considering Pinsando's work, and I'm assuming from the way they were talking about, it is a working model. There is something that is functioning already. Why wouldn't we, and if they are willing to contribute into the community, why wouldn't we start there and go to the next steps from there?
Yeah, I think that to me is a more progressive approach, right? So I don't see why we start with that.
I'm not sure if they're on the call. I don't have any problem with Pensando offering anything that they want to, right? So that's up to them. Is anybody from Pensando even on this call?
Yeah, they are.
Yeah.
We've got Mukesh,
Yes,
we've got BJ and everybody.
Yeah, we are here, Gerald. So probably I think we should work out details on what would be the means of this contribution. And the algorithm is there, the framework is there. We can probably dig more on what else we need. And I think Balki went through this thing on what we do. There are some.
Yeah, you did a
messaging
long presentation last week, and it's just obviously details are obviously missing, but there was quite a bit of detail in it.
It looks like Pensando's method also carries the metadata that we intend to carry, and that could also probably bypass the slow path by design in the standby. Those details would be good to have, and in terms of acknowledgements, if there is any optimizations that we can do offline to batch them.
See, I think some of this metadata that is sent is kind of specific to the implementation because this thing. But what instead of exactly what is carried, I think we can definitely share what is the information we carry instead of format and stuff like that. And that should, I think, implementation wise, that might change. That might be the opaque, analogous to whatever is there as opaque fields in the data.
So I have a one comment on your proposal, right? So I think on there is a initial sync which is more on the control plane to sync those messages, right? So so for that part, I think do you expect your drivers to initiate those connections, or actually all those connection information that we can actually use a Sonic to query, and then basically the Sonic would be doing those those message transfer between the active and standby. I think in that case we just need to define some SAI APIs to query the state and then be able to get the state and then do the synchronizations. You see what I mean?
Yeah, go on. Yeah, for experiencing this happens from the direct HA module itself today, because that additional hop kind of would add to the performance this thing. So this happens directly today from the
But they just
our
pure
HA driver or the
yeah, but I don't understand the additional hop, right? So you just your SDK, your site gets you can have the site API, bulk API to get those state directly, and then just have the TCP sessions to be transferred, right? So that in that case, I think on the other hand, it's really improving the interop, right? So basically then different versions we can then the Sonic will be controlling those message format, right? So between versions we don't have to argue, okay, what exactly are the wiring trends. On the inline part, I think we need to define those more clearly.
right. So I think one thing is maybe we can have a little more this thing there, but one thing is whatever is the sync that the control plane is doing, there is some for optimization. There is, I think, the control plane also keeps track of what state is changing in between, because it's not an atomic thing, right? When we are doing this thing, there might be connection state that is changing incrementally as we are syncing.
Yeah.
We'll need to. That probably is some complication, I think, since it's running together. We're able to do it in some way. We need to think about it on if we need to expose it as an API where some other external entity is going to do the bulk sync. That handshake between the bulk sync and the incremental sync, probably we need to think through. That's possible.
Yeah, but
if it
this
is, then we can
but this
expose
is like those VM line migration scenario, right? So we're at some point we have to freeze one side, right? So and then go to the other. Because if you don't freeze, your memory keep dirty, right? Keep dirty, so you never get to a point where you have all the memory being cleaned up and synced.
So it's not
Correct. So
actually
that's
quite like that, Gohan. We do a perfect sync, which means there's a time. You go from a timestamp or a color. You send over all of the data from that, all from the bottom of the table to the top of the table. When you're done that, you are done the bulk. In the meantime, you have been doing inline all throughout that, so it is in perfect sync at the end, and there's nothing more to do. Once you get to the top, you're done. So it's a little different than VM migration, and we've documented that. It's called perfect sync, and it works a little differently. Perfect sync just means you know exactly when you're done. You go to the top of the table, you're done. There's nothing more to do.
Yeah, but my comment is still, can we get those non-inline part to be controlled by the Sonic software, right? So what would be the next step?
Yeah, I think that's a good idea, and then the coordination of how it tells it's done, right? It just needs to be like, I'm done now, and because you need to, at that point, you need to do the switch over at some point, which is a separate, as Michael wanted, it's like, it doesn't matter whether you're done or not. When you're done, then you need to signal it, and then SDN will come down and say, okay, now advertise BGP, at a moment later, whenever a time of their choosing. So that sounds like it would be good to coordinate that piece. And there's, as you said, there's no reason in the bulk sync why you couldn't just use it, the Sonic, let's call it Sonic messaging, whatever that means. Because it really is just a transfer of data, and it's in the background, and it's actually not as fast as the inline, right? It's like it can be done as a background task because you can take 10 seconds, 20 seconds, 30 seconds if you want to finish, right? You just go to the bottom of the table to the top of the table, and when it's done, it's done. So it sounds right. That would get us one step closer to interoperability. At least the bulk sync could be interoperable for everyone. But everybody still will want some metadata added, so that's the only caveat to that.
Yeah. Yeah, so I think the longer, I think from our experience, I think Balki can this thing. So I think the longer we take for finishing the bulk sync, we find that it gets more and more complicated with keeping the integrity of the two sites. This thing, so we try to finish it. I think Balki
Right.
What
can
should
chime
be
in
done as
from
fast
his
as
implementation.
possible, for sure, but
Yeah,
it doesn't have to be done at the same rate as inline. I mean,
Yeah.
inline
yeah,
has to
definitely.
happen
Yeah, not at the same. Yeah,
real time. Yeah.
The receiver side, the packets will be queued, but from the sender side, if we batch them and we take time to pack the different datas of different flows in one packet, there could be an update in the flow as we are parsing the whole table, and that may be sent outside of the bulk sync. In that case, it would be out of order when the bulk sync packet arrives at the receiver.
No, you can't get out of this. So you can, you're talking about when you get an update to something that
Yeah,
was,
already
yes,
packed, but not.
that's the one thing that we'll need to discuss, Martin. You brought that up before. It's a good point. It's possible to get a race condition there, and maybe we can work with Pensando on what they've done there.
So one thing about the API, whatever that Goan was asking for. So last week when we were presenting the node pairing, right? So we, in the picture, we also presented those APIs, right? Like there is after the configuration, there is a HA start, which is coming from the controller, which is the triggering point at which the bulk sync basically starts. I mean, in the sense the pairing starts and the bulk sync starts. And likewise, after the bulk sync ends, it doesn't automatically pair up or it doesn't automatically advertise the IP address. Again, there is this activate admin role API. Once you push that, then the advertisement starts, and then the pairing, and then the role gets established. So basically, it becomes active and standby. And you can go through that node.
Yeah, I get this part, but what my comment is that some of this protocol stuff, right? So I think it would be more simpler if if the SAI gives the API to query all those flow state, and then we can easily those sync HA star, those kind of things is really moved to the Sonic implementation, right? So you just give us APIs to query all your flow state, and some kind of notification when the flow state changes, and then we'll get all those, and we'll do the implementation in the Sonic to do all this state, to do this slow pass synchronization. And but for the fast pass, yes, I think we will basically rely on the, your inline mechanism to do that.
So Guan, the HA state or the role, whatever we transition, right? That is actually streamed, through our right? Streaming mechanism. So it is actually can be seen by the controller, and based on that, it can basically invoke these HA start and activate admin role APIs. It is basically you can make it programmable on your side as to when you want to start the pair up and start the role establishment, etc.
No, I still understand what you're saying, but I'm saying it's better to move those complex, those phrases implementation, state transition diagrams, the logics into the Sonic, right? So instead of in the SDK or SAI, because that's just common, right? So it just we implement once, every vendor will just get the same benefit, right? So then we don't have to debug this over again, right? So what we really need from your SAI SDK stuff is to get those flow state, so we can start using like gRPC to transmit all the state from active to standby, instead of letting your SAI or SDK to do that transmit, the wiring protocol, right? So those things that can be implemented at the Sonic layer instead of the SDK layer. And on the other side, I think is inline, of course, have to done at your ASIC level.
It seems to me that this is gigabytes of flow state that has to be moved, like tens of gigabytes from from one DPU to the other DPU.
That's
And
correct.
I think you're suggesting that all of those tens of gigabytes go up to the controller and then back down to the other DPU. It seems like really.
No, not the controller. What do you mean by the controller?
You're saying like, okay, so you're saying like Sonic running local on the DPU will query the flow state and send it to the other DPU.
Yeah.
So the API, the SAI API you have in mind here, is it a get me a flow and then I'll send a flow and then get me another flow and I'll send a flow? Or is it more like start the bulk sync?
Yeah, it can be, because that would take days, and we all know that.
You know,
That
like
wouldn't work.
get all the flows, right? So bulk
Yeah.
API to get all the flows.
Get all the flows.
Or could it be something like, to start with, can it be an API to say start bulk sync kind of a thing, where the DPU, the SDK can do the reason I'm saying this is I think we can, I don't have an answer on specific things yet, but I think if you go back, the hand holding or the coordination between the incremental, the data path, and this bulk sync that we have, I think it might be a little more involved if these two things are happening with two different brains. It
So
kind of makes it easier, so it's together. But if
I
we
think
separate
for
this out,
for that one, right? So whether we start with this one or start with you know, this get flows, I think I would hear more opinions on, but I think the benefit of doing this simple get flows and the Sonic manages that is that just one implementation and it will fit all the vendors, right? So it also improves the interoperability that Gerard wants, right? So then we just only have to worry about the inline part, which it could be much simpler, right? So, however, my preference would be that let's start with one implementation, and then it's not if we start with another approach and then later to move to a second approach, that means we're duplicating our efforts, right? So if people all agree that moving those state machine to the Sonic part, then I think we should start with that, right? So basically we define the APIs, and all of you guys can and with enough details, and all of you can implement that, and we take care of the Sonic part, and it will benefit all of you guys.
Definitely,
Hey, Gohan,
I think this
I
should be
have a
in
quick
Sonic.
question.
Yeah.
I have a quick question on your suggestion, Gohan. You're talking about bringing all these flows into the software on the Sonic side, and then earlier we had discussions about whether or not we will be bringing all these flows or all these flow informations in the memory on Sonic. Remember, we are running Sonic on a DPU, and as such, running on a there is no external CPU, right, on an appliance where you have DPU. So essentially, you're running Sonic on a DPU with limited memory, with limited CPU. How do we believe that we are going to bring in all the data and be able to really store and be able to process and send out all this synchronization from there? What's your thought on that?
Yeah, that's a good question, right? So I think my answer is that, okay, so I think we understand, there are some ARM core CPUs to do, because it's running the Linux, right? So running Sonic, there must be some CPU and the memories there, right? And also, I think what really doing here is that we don't have to get all the flows to be stored in the memory and start transferring, right? So we can create some kinds of a ring buffer. And then as soon as we, get flows from your SDK, then we start transferring, right? So, there's a, basically you don't have to store all the flows in memory and then start doing transfer. You get them, as soon as you get them, you put in the queue, and then, that queue, and then you move those, you send those, through your, gRPC channel to the other side, right? So then and then you can define, depending on your system, you can define what would be the queue size, right? So then you don't have to run all of the, and then then the transfer, just as soon as those flow being transferred to the other side, you can remove those messages from the queue, and then you're freeing, and you can get more state from your SDK, right? So
and it can in that way it can be a continuous send. So that's
that
exactly. Seems working. You don't transfer all the flows to Sonic and then Sonic transfers it. Yeah, it would just be a continuous transfer.
That will also work for resimulation whenever we get to discuss that as well.
Resimulation is something. Resimulation is something different. Resimulation is where you're basically redoing the slow path on every connection. It's a different exercise altogether.
Right, and that might be a requirement. The syncing will be a requirement when it comes to resimulating as well, isn't it?
Oh yeah.
Yeah.
Are you saying? First of all, HA always has to be followed by a resimulation, if that's what you're saying. And
right.
We should standardize on that just for good measure, because you don't want the policies could be slightly out of sync between them. And and it's just good practice to make sure that you resimulate after you've done this bulk transfer, this perfect sync. Right. So agreed on that. Yeah, it should follow after the perfect sync. It should be resimulation. It should be the sequence.
I have some performance concerns about this plan. I mean, I think it's logically feasible, but like Gerald, you were saying, like the bulk sync can take a long time. It can take 10 seconds, 20 seconds, or 30 seconds to complete. But
I think it takes as long as it takes to send about tens of gigabytes of information. It's a lot of information.
Yes, like maybe 30 million flows on that order, right?
Yeah, it can be.
So like say it's like, I was thinking like, I think you used the number 30 seconds at one point. That's would have to do 1 million flows per second up through the Sonic and out. I don't know if we could hit that. Like it might.
I don't know if anybody knows.
It might be minutes, right?
I don't know if anybody knows the exact time. We should actually load up our unit actually and figure out that. Yeah, I don't know how long it's going to take. I'll be honest. So if you're running a hero test, that means you have maximum number of flows. In that kind of test, and you did a HA switchover, yes, you would have to transfer that amount of flows. Like it would be a substantial amount of flows. So I think one to do here is we should probably try that, because I can't tell you how long that takes.
But that's only for the
Balki might know. Balki, do you have some idea?
Sorry, that's only for the initial sync, right? So it's not for the incremental. The incremental is always in line, right? So I'm not.
We're just talking about the bulk sync, not the incremental stuff.
Yeah,
incremental happens real time. We're talking about like when you're doing your perfect sync, which is your bulk transfer of what you have. That can be a lot of it.
That's only happen at the first time, right? So it's not happen because after that
it just happens under switchover. But what they're saying is when you do that, when you're bringing up a device, it doesn't happen over switchover, by the way. It happens when you're bringing up a device that's new, and it has to be undergo this. And so I think we don't know the answer to it. Like, I don't know how long it takes. We should just measure it and figure that out, whether it's 10 seconds, 30 seconds, 2 hours. I don't know. So I think Pensando could probably give us a rough estimate.
Balki might know.
Yeah, I mean,
Balki might know.
Yeah. So Gerald, it depends on the number of flow entries that we have, right? Number of sessions that
Well, assume 32 million or something like that.
Yeah. So with fully loaded, we observed somewhere close to 60 to 80 seconds.
Yeah.
Okay. Well, that's very reasonable, actually.
But let me ask you this question, right? So because in that sync, right? So you are also set up like a TCP connection to do that kind of sync, right?
There is
Yeah, so the incremental sync is happening in parallel.
No, yeah. I'm not talking about increment. I'm talking about the initial bulk sync, right? So you are also setting up TCP connection, right? So
yes, we have a TCP connection in our between our control plane on
yeah. That's what I'm saying, right? So think about, right? So our SDK, our syncd process, and your SDK is running the same process, right? Your side is running the same process, right? So what I'm asking is that what my thinking, my approach is that the syncd will query all those flows, right? So incrementally, right? So as soon as get flow, you set up the TCP connection, send to the other side, right? So the same way as you did, right? So therefore, I'm not sure, if we're talking about overhead, what kind of how much overhead would that be? We just add a new API call to get all your flow state, which you probably should do that internally in your SDK. I'm just saying, expose that to the side, and then we get it, and we set up the same TCP connection to do that sync, right? So I'm not sure, just some kind of a wrapper of your SDK wrapping to the side and get that function call and send it, right? So but the benefit is that all the vendors are aligned with the same implementation for the state transitions for the HA now.
Right. So can we do one thing on? I think the way I think the state transition seems like a reasonable thing, right? We get all the state codified on what are the states that the peers need to go through to get this. Now, the only thing, like I was saying, that I have this thing is to work out what are the dependencies. If we say that the incremental sync, which is the data path sync that we are doing, is going to be specific to the to the vendor or to the mode that we are in. If you just pull out just the bulk thing out, but leave this thing to be independent of per vendor, then I'm trying to see if there are tie-ins between the bulk sync and the data path sync we are doing. How much advantage do we get from that? Maybe we can go back and see. I'm just saying that there is a tie-in between the two. We can go back and see what are those tie-ins. How much is the tie-in between when we are doing bulk sync? What are the dependencies we have with the data path sync too? Maybe depending on that, we can see, is there an advantage in pulling out just the bulk sync out, or leaving the data path sync to be implementation specific, or does it make sense to separate it out?
For the data path sync, it looks like there is one open, which is the metadata that is being synced. That part, since it's not fully defined, maybe we could use XSight's proposal for that part, right? On how to define what is the metadata that needs to be synced between active and standby. That was one. And the second one was that in case of, a proposal where if we have to mirror a packet with a separate type of encapsulation, will that affect CPS? And the third part that I wanted to ask was the inline synchronization between active and standby, the acknowledgements in that part, can they be batched?
Yeah. The batched for the inline, I think the problem will be the buffering in hardware. That might be this thing to buffer for this thing.
Sanjay, just to clarify, in the AMD proposal, there is no buffering of the packets, right? You just get it, you send it out to the standby does his thing and sends it back.
Yeah,
there's no buffering.
Yeah, for the data path sync, yeah.
That's one comment that I have. I don't believe like that is compatible with the other proposal that has buffering.
So the bulk sync, the control plane sync is batched in the sense you can think of multiple records go in this thing, but not the data path sync.
So this is John from XSight. It's possible for the data plane sync to be batched. It's up to the sender. If the sender has the ability to gather up multiple messages, whether those are entire packets or digests of the packets, it could send them all in one single bulk to the receiver to be synced. But like I said earlier, like it's up to the receiver to decide what the maximum bulk size is. If the receiver is only capable of one at a time, then the sender will only send at most one at a time. So like the proposal that we had allows for the possibility of bulking if the sender has the ability to do bulking. And of course, the receiver can decide whether it's going to accept bulks bigger than one. So, there's an optimization there. I mean, we've done some math there's an optimization if you can send multiple syncs in the same packet. Also, there's an even further optimization if you don't send the packet, if you just send the digest of the packet. That the proposal that we had would allow for those possibilities.
Okay, so I think we're running out of time, right? So what do we do next? I think it seems like people say, okay, maybe let's start, improving, iterate on this AMD proposal and get it, and get it closed and sort it out, grade, right? So is that what the thinking is?
Yeah,
For
I
me,
agree with that. I agree with that. I would suggest that if AMD Pensando can kind of abstract out the details and have a metadata definition, which is probably a little bit of some of the things standard, but leave the room to have proprietary mechanism between the vendors maybe. And if we can have that details shared with the community, I think that's a good start. I think everything else are next level of details, right? Whether we should batch it or who should accept, all those are next level details. I think having a working design that meets most of the needs, I think it's already there. There is no need to reinvent it.
Yeah, I agree with that, because this is a working version. A lot of it basically, at least we will have one example, a working example from where we can build upon further. And then it's good to have a working example as something without actually, without that, we all have a lot of theory, right?
Mm-hmm.
Let's go with that. So.
Okay. So we have a Broadcom and Marvell, right? So,
fungible.
That's
fungible.
fungible now.
Sorry. Okay.
It's okay. Go on.
All
Long
right.
time.
X Marvel.
This is John from XSight. I don't think that the AMD proposal is incompatible with the XSight proposal. So I would be perfectly happy to work, have the community work through all of the details of a working HA and then see if we can map it into a framework that would then allow for future optimization and future interoperability. Because I don't think that what we propose is incompatible.
All right. I mean, let's start with AMD, right? So yeah, but what I'm hearing, yeah, you're okay with
but
start
I
with
think
AMD.
what John is saying is also true, that okay, we are starting with that, but of course it matches with our expectations and we build upon that, and then we see how it maps to a broader theme and broader objective, right?
Yeah, we can start with that. I mean, then we move along and see, get more comments and improve the design. Okay.
Agree. John has some of the things that defines some of the metadata. I think it can be used in conjunction with what AMD has. And yeah, if we can keep the options open to optimize further, that would be perfect.
Okay. Makes sense.
I'm going to stop the recording and I'll post it to the YouTube channel. And for not having a specific agenda, we seem to have filled up a lot of time and talked about a lot. So thank you, everybody.
So next meeting will AMD to do some iteration on that, or what would be the next topic?
So what
We
I
can-
have
we
written
can,
down is Sanjay will check out bulk sync and data path sync, AMD to extract details and share. John's happy to work with AMD for future optimization and compatibility. And then I know Marian has some APIs that he's been working on. That's what I have written down. Do you guys have anything? I'm not the work group leader, but I'm just taking notes.
I think
Well,
Sanjay
APIs are up,
can-
so I would ask maybe AMD to review them. I don't know if you were present on previous meetings. It's in the pull request. I can share it again.
Sorry, what was that, Marian? I missed your first.
The APIs for control plane for configuring HA.
Sure, sure. Yeah, we'll review that.
Is that enough?
I think
Rohan?
we also if Sanjay and Balki if they can bring in more detail as we discussed, right, beyond just the presentation, if there are any something they want to open up in terms of the design spec or whatever, right, which has more detail into it, we can review that as well.
Are you agreeable to that, Sanjay? Or
Sure. Yeah, we'll get back and
okay.
regroup again and see if we can get it to some one level down further. Sure.
All right. I'll see you guys
Yeah.
next week.
Thank you.
Thank you.
Thank you for your time. Good conversation.